Hello and welcome back to the next video on using the addition rule for probability. And in this particular video, we're going to be focusing on mutually exclusive events. Now remember, a mutually exclusive event, or two events are meant to be mutually exclusive if they have no common outcomes, or basically if they cannot happen at the same time. So that's just a bit of a refresher from video 1. Now remember, graphically, this just means that our Venn diagrams have no intersection between them. Two circles are separate in terms of the event. Okay? Now, in our last videos, we've talked about this rule here. Okay? The probability, the addition rule for probability, if they are non-mutually exclusive, okay, is given by P of A or B is equal to P of A plus P of B minus P of A intersection B. Okay? Now, when our events here are mutually exclusive, this formula becomes a little bit different. Okay? Think of this here as being the overlap. Alright? If there is no overlap occurring, right, there's no common outcomes. So the probability of something happening in both A and B would be 0. So this just cancels out because it cannot occur. So therefore, what you end up with when we're talking about mutually exclusive events, the addition rule simply becomes the probability of A or B occurring is equal to the probability that A occurs plus the probability that B occurs, all because this term here is wiped. Okay, so let's have a look at how we would approach this in some questions. So in this example, right, the question asks you, for a standard deck of 52 playing cards, what is the probability of drawing a heart or a black card? Okay? So let's just stop and just think about whether or not this particular problem has two mutually exclusive events, okay? The first event being drawing a heart, right? So we'll say H for drawing a heart, okay? Or drawing a black card, okay? So B, and that's going to be our second event, drawing a black card. Now, remember, for them to be mutually exclusive, it means that they cannot happen at the same time. And if you think about a deck of cards, if we were to draw one of them out, okay, you're either going to get a black or a red card. Now notice, let's just think about the suits on a particular card. We have, in red, we have our hearts and our diamonds. And in black, we have our clubs and our spades. Okay, notice that hearts are a red card. If we draw a card out of our deck, it cannot be both a heart and a black card because it's in the red suits. So therefore, they cannot happen at the same time. They are mutually exclusive events. So let's look at calculating the probability of either drawing a heart or drawing a black card. Now, I just want to highlight here, we know that this is going to be an addition rule question because of the word or. Okay, they're mutually exclusive, so the formula we're going to use is P of A or B, remember that little symbol there means or, is equal to the probability of A plus the probability of B. Okay, so because they're mutually exclusive, we don't have to minus off the intersection, just remember that. Our formula changes depending on what type of problem that we're looking at. Okay, so let's look at the probability of drawing out a heart. Okay, so the probability of H or B, okay, is equal to the probability of H, so the probability of heart occurring. And let's just think about this. We have 52 cards in our deck, okay, a quarter of which are hearts, okay, so that's 52 divided by 4, that's going to give us 13 out of 52 chances for drawing a heart to occur. Plus the probability of drawing out a black, well, out of 52 cards, the blacks are exactly half of the deck. So half of 52 is 26, okay? If we add them together, we end up with 13 plus 26 is 39 out of 52, okay? Which is exactly 3/4, okay? So that is how we calculate the probability in a mutually exclusive problem, okay? I hope this helps. Thank you.